Alright, so we're going straight into the tutorial now. For the first question, we are asked to prove a particular relationship, or we're asked to state whether or not it's true or false. If it's true, we need to prove it. If it's false, we prove that it's false by giving an example that shows that it's false. Now the first thing that we're asked to consider is whether or not theta of 2 to the n equals theta of 3 to the n. Is that true? Why do you think so?
Based on the properties, because it will be more than or equal to. Is it more than? No, it's not more than.
Alright, remember from the slides, one of the things that we can use to test the class that something falls in is by checking the ratio. If something is in omega, alright, let's start with theta. If two things are in theta, then I'm just write that for theta to be true, for a theta relationship to hold, out of the way. Then limit as n approaches infinity of f of n to hold between f of n and g of n. Limit of as n approaches infinity of f of n upon g of n should be equal to some constant which is greater than 0. Make sense? If we check the limit as n approaches infinity, that tells us a lot. Question?
Jonathan, you pause further, please.
Okay.
Why am I not seeing the video again?
One sec.
It's on the bottom of it.
Is your Pauline is in there? Give me a sec. Can she hear?
Yeah. Okay, yeah. It's hearing you.
You know what? Let's put this further up so we can probably see it. Let's
Thank you.
Okay. Alright. So by checking this ratio, limit of f of n upon g of n as n approaches infinity, we can learn a lot. If that limit of approach is a constant, then we know that those two pretty much grow at the same rate. One doesn't really overtake the other. If the limit was approaching 0, then we would have seen that f of n would have been much smaller than g of n. So then f of n would have been in big O of g of n. If the limit was approaching infinity, then f of n would have been much larger than g of n. So f of n would have been in omega of g of n. So those definitions are actually in the course manual. Now, we're going to use that property to help us decide whether or not that is true. So we can check, checking limits as n approaches infinity of 2 to the n upon 3 to the n Well, what do you think that limit would approach?
Which one? Well, f of n is smaller than g of n.
So as n approaches infinity, this whole thing would approach
0.
and
Yeah. That's
we see that the limit of that is equal to 0. So therefore, they don't have a theta relationship.
Sir, so if it were 3 to the n over 2 to the n, then it would have been okay for a theta relationship.
Alright. The limit approaches 0, so therefore 2 to the n is actually in big O of g of n. Now, the limit of 3 to the n upon 2 to the n, that's n approaches to infinity, would be infinity.
Okay.
So 3 to the n is in omega of g of n. Alright? Alright, next one.